let's get started with 43, isBeautifulString. Oh, look at that. Okay, so a string is said to be beautiful if B occurs in it no more times than A, C occurs in it no more times than B, etc. So we're given a string, we want to check, is it beautiful? According to this definition anyway. And keep in mind, it doesn't have to be in order. So like we look at this one and we know that that's false because there are more B's than A's, right? But if it was like A, B, B, so like if this one was an A instead of a B, it'd be fine. It'd be no problem. This one over here is false because there are no A's. So definitely, 2 is greater than 0, so that's not going to fly. But if we look at this one over here, like this one is true, and that might seem a little strange because B comes before A. So it's not the order that's important here. That's something to keep in mind. Order is not something that's really going to matter in terms of like the characters in the string. I mean, like I guess we could put it in order and that might make things easier, but I don't even think we're going to do it that way. The main thing is if we look at this one, we look at the total number of A occurrences and we see there seem to be 3 of them. There are also 3 B's, and that's okay. Importantly, it's okay to it's okay to have the same number of characters, like the same number of B's as there are A's, the same number of C's as there are B's, etc. But it just can't be more. Okay, so 3 A's, 3 B's. How many C's? Am I only seeing the one? I think I just see the one. So 1 C, 1 D, 1 E, 1 F. So a bit of a long tail on that one, but the main thing is that everything after an F, so like G, H, etc., there's going to be 0 of those. And that's fine. And I guess now that I think about it, it's kind of an important condition that it doesn't have to be like strictly decreasing each time. Like it doesn't have to be like 5 A's, 4 B's. Like the main thing is that if it had to strictly decrease each time, then what if there's 0, like 0 H's, 0 I's, 0 J's, etc., right? So it makes sense that you could have the same number of characters from one to the next, but just not more. Okay. And why this is considered a beautiful string? Well, I don't know. Beauty is in the eye of the beholder, right? So anyway, we can follow through with this. We can definitely write a nice algorithm for this. But the first thing we're going to need to be able to do here is to actually be able to identify how many times a character is occurring in a string. So like if we're just given a character like, let's say, lowercase a, how many times do you see that in the string? So that's what I want to do to begin with. So let's just make a bit of space here, carve out a sort of a working area for us, and I want to write a function. I'm just going to call this count, and it's going to take an input of character. And for now, what I just want to do is return count of A, which would do nothing right now because there's nothing in here, but let's change that. So, I guess we could say let total be assigned the value 0. We'll start with that, and we want to return total ultimately, like the number of times. I guess I could have called it like occurrences or something like that. Maybe that's better, right? Occurrences. Yeah, I like that a little better. It's longer, but I think it's going to be worth it because otherwise it's sort of like total what, We want it to make sense to the reader with as little explanation as possible, right? So if someone was watching the video on mute, or like if we didn't intend on writing any comments or something like that, as much as possible, we want our code to be self-explanatory. So, okay, no occurrences of the character yet. How are we going to determine how many occurrences there are? Well, let's loop through it. So we'll say for let, I guess we'll just say let C of input string. Or, you know what? Letter. Might as well. I was just talking about being self-explanatory. I think, like C, the reason I was going to use C is because we've already used character up here. But again, I want it to speak for itself. So, okay, letter of input string. Basically, the idea is that if the letter happens to be this character we're looking for, well then let's increment the number of occurrences there. Okay, so let's try that. Is that going to work? Can we count the number of A characters? Yeah, there are 2 in this one, so that's correct. There are 3 in this one, as we determined previously. None of them in that one, and that was the problem, actually. Two of them there. Okay, awesome. So that looks like it's working. So that's nice. We've got a reliable function for counting the characters. So I guess we might as well use that now, right? So we'll go through each character and we'll just try to say like, yeah, is it okay? You know, is this an acceptable number? So first of all, what do we consider an acceptable number right off the bat? Well, technically anything. So like, okay, I'm gonna do a new variable. We're gonna call it limit, and we could make it like an enormous number. You know, we can make it something that's just like huge and just for the beginning. And the reason I'm doing that is because we want to do something sort of like this, like for let. I guess I'll use character again here, and it'll be assigned the value of a. We want to keep this iterating up to and including the point where character is going to be equal to z. And then ultimately we want to be doing something kind of like this, you know, character plus plus. That's probably not exactly what we'll do, but we'll talk about it in just a sec. So for now, inside the loop, I just want to sort of lay down the foundation of how this function is going to be working, of you know, sort of the structure of our code here. So basically, limit. What's this all about? Well, I'm just using limit to sort of say like to compare to the previous number of characters, right? So I guess we'll do something like this, like character count be assigned the value of count character. Right? So it'll start at A, it'll go all the way to Z. And then what we want to say is if that character count is above the limit, you know, if it's greater than the previous one, well then just straight up return false. I mean, that means like that's not something that's supposed to happen, right? You're not supposed to go over the limit. You're not supposed to have more characters than the previous one. This is maybe what's going to sort of tie this together a little bit. We are going to now reassign limit to be the current character count. Now that's assuming it gets past this line here, and really this is just sort of one line, so it doesn't need to be any more complicated than that. And if it makes it through this whole entire loop without this ever being a problem, without the character count ever exceeding the limit, well then at the end that must have meant that it's true, that it is beautiful, right? Because it made it through this kind of it made, like, for every single character, there wasn't a single one where the character count was greater than the limit, which is the previous character count, like we see right here. Okay, cool. So we know that this function works. We're good with that. I think we have a good idea of how this is all going to work, but it's this that I'm a little skeptical about. So let's try running this and we'll see what happens. And I'm kind of I was kind of expecting an error for this one. Well, at the very least, we're getting almost all of them wrong. It's returning true for every single one of these things, which means it's making it to the end of the loop each time. And the issue behind that is, well, actually, here, let's see how many iterations of the loop are actually being captured here. So we're going to do a console log. It's going to log the current character for each iteration here. So for every time it executes, it's just going to show us the character. Okay, so it gets to A. This one also gets to A. They're only doing A. Like, basically, it goes through and it says, okay, character is A, great. Is character less than or equal to the character Z? Yeah, A is less than Z. So it goes through this, does the console log, it does all this other stuff, and then we do character plus plus. And at that point, it's like, what are you talking about? What do you mean plus plus? We're not talking about a number here, we're talking about a string. So it's more complicated the way we have to do this, the way we reassign this. And look, hey, if anyone here knows of a better way to do this, a more efficient way to do this, definitely, you know, let me know. I'm open to hearing about it. If there's an easier way to do this, I would love to hear that. But the way I'm aware of is to do something like this. So we've talked about character codes before, you know, we talked about this whole ASCII table business. So we're going to convert it to its character code. That's the idea. So instead of an A, whoops, that's an image. Instead of an A, we're going to make it a 97. And then we're going to increase 97 by 1, and then we're going to convert it back into a character or a string, right? So we start with A, convert it to 97, add 1, convert it back into a string. Okay. So maybe, like, okay. I could just put this all in line here, but here's what I'll do. I'll just say character is going to be next character. Okay, what's next? Well, it's a function I'm about to write. So function next is going to take in a character, and what's it going to do with it? Well, it's going to say let next character be assigned the value of, well, actually, let's not get ahead of ourselves. Let's say let character code be assigned the value of character.character code at. So that's a built-in for strings. And as you may remember, this built-in, like we could give it an index or something like that. Actually, that's a high index. But anyway, we could give it an index if we wanted to. We could give it like a 0, because really that's what we're talking about here. But if we don't give it an index whatsoever, it's just going to take the first character anyway. And in this case, that's the only character. So nothing to worry about. Now, by the way, some languages do distinguish between a character and a string, but not JavaScript. In the same way that it doesn't really distinguish between like a floating point number versus an integer number, like a whole number. Okay, so we've got our character code. Then let's say maybe let next character be assigned the value of string dot from character code. And what character code? Well, the one we found, but then +1 on the end of that. And then we're going to return the next character. That's the goal here. Okay, so that's what next does. It takes an input of character. Here we are giving it the character that begins as A, and this should make it go to, B, and then eventually C, etc. And a few more spaces than we need there. All right, let's run that. Ooh, well, I have to say that's very nice to see. If we look at our console log, it does appear to be going through all of the characters we need, the whole alphabet. Cool. Well, now that I'm thinking about it, there is another way we could do this. There is a simpler way, one that we could do this without this whole next thing. And okay. Here's another thing I want to say. Like next, we technically don't do that. We don't need to do that. Like we could say something like just string dot from character code, and it would be character dot character code at +1. We could just do that all totally in line. And it looks a little ugly, but is it going to work? Yeah, it's going to work. So we could do it that way. Like that's an option. It's available to you. But as we were doing this, actually, I just thought of a different thing we could do. So we used a for of loop somewhere, right? Yeah, up here. We used a for of loop. So I was thinking, why don't we do the same thing here? So for like character of, well, of what? Of A, B, C, D, E, F, G, H, I, J, K, L, like I said. So basically the whole alphabet, and hopefully I didn't make any like embarrassing mistakes in there. So yeah, we could just do something like that. I don't know. I think that's actually like fewer bytes. Like I think this is actually shorter. But is it nicer? I don't know. That's really up to you. Is it more beautiful? If we're being apropos to this problem, I don't know. That's really up to you. I think it's cool. Like it's kind of neat, but is it the best? How about this? We'll roll with it for now. And in the meantime, we're gonna try to maybe switch this up a little bit, because now I'm looking at this other for of loop, and I'm thinking like, maybe there's a different way we can be doing this whole count thing, right? Maybe we can sort of figure out how many characters there are going to be, how many instances of a character there are going to be in some other way. So, okay, I'm going to switch back to what we had before. So we had something like just that, return count A. Yeah, and it was giving us the number of instances of the letter A. Great, seems to be working. Okay, but now we want to do this in a different way. I don't actually want to do a loop here because, all right, this might start to sound a bit familiar. We sort of talked about this situation before, but basically when we're looking at a string and we're looking for some sort of pattern or properties about it, usually when we're trying to, investigate a string, we're probably going to use a regular expression. So that's going to be the game plan here. We're going to use a regular expression for this one. That's the idea. So we could just do something like, okay, we'll say let regular expression be just this. We'll make it the character A for now. And then a little later on, we'll talk about ways of generalizing this, but for now we'll just make it the character A. And we could just do something like return, how should we do this? I guess we want to do like a match on this, so input string dot match. There are other ways we could do it, but let's go for that for now. So input string dot match, regular expression. And what we find here is that some of them are going to give us an array of matches, or at least they should. Yeah, like this one, it's giving us the A. This one is also, if we look at third, that's giving us null because we didn't have a A in this one. So, okay, let's think about this. Well, okay, we're not just looking to see if it does have an A, we're looking to see how many are there. And right now, like there should be 3, we're only getting 1 there. Well, the reason is because we didn't have the G flag on. We gotta have our G flag that stands for global. You put it at the end of the regular expression, and it means, okay, I won't just look for one of those, I'll look for all of those. So it found all of them. Cool. Yeah, in this case, there are 3. But if there are none of them, still, it's gonna be a null. And the reason that's gonna be kind of an issue is because really, I know they're both gonna be A. I don't need to know the contents of the array here. I wanna know the length of the array. But then it's going to say on test 3, but there's no length property of something called null. So we'll do it differently. We'll say let matches be assigned the value of that. And if matches, so in other words, if it's not null, then I guess we might as well do a full-on, return matches dot length, and else return 0. And now that I'm looking at that, I'm thinking we could do this in a smarter way. We could say return matches, do a little ternary operator here, right? So if this is true, it'll return the first thing, which should be matches.length. And if it's false, 0. So this line right here, exactly the same as this line, well, there's several lines over here. So that's nice, it's nice when we can be efficient like that. Let's run that. Let's see if that actually works now. So the first thing we should notice is that no errors, that's good. The other thing we notice is it's giving us our character count. So it's giving us the 3 here, it's giving us the 2 here, it's giving us 0 here, exactly what we're looking for. Okay, so that's nice, right? We gotta love that, so that's working, but there's a bit of a problem. There's a bit of a problem here, and it's the fact that I'm only looking at the letter A. Even if I say, oh, don't count A, count B. I've hard-coded it to be counting A here. So yeah, there should be 3 B's, but it's just counting the A's. So we don't want that. We're gonna have to do our regular expression in a different way. So this brings us to sort of the more object-oriented way of doing a regular expression. We can say new regexp. Don't want to forget the capitalization there. And then in here, we'll just put whatever we want it to be. So for now, I'll just hard code in the letter B. And the thing we're going to notice is it's still just saying 1. And the reason for that is when we do a new regular expression like this, it's not by default going to have the global flag on it. So we actually need to give that as a second argument. Now, by the way, you could put whatever you want in here. And at this point, okay, so that's good, it's working. But what I was saying is that at this point you might be wondering, like, well, why would you do it this way? It seems like it'd be a lot easier to just do something like that, right? Like, doesn't that seem a lot simpler than all this? Oh, didn't mean to do that. Doesn't that seem simpler than all this stuff up here? And yeah, but there's a problem. If we tried to put in our general, character, then it's actually going to think that we're talking about like the letter C, the letter H, the letter A, the letter R. If we want to slide in a variable, the value of a variable, we're going to have to do it using this more object-oriented way. Okay, so we do our new regular expression, and now let's see if this is actually going to accurately count how many B's there are. Yeah, looks that way. 3 B's over there. How many B's over here? Also 3 B's. What about in this one? Yeah, there were 2. Okay, so that seems to be working. In fact, it seems to be working in general, so let's try executing this now. Is it going to work? Yeah, it's going to work. But you know what? I actually haven't checked yet if it's going to pass all the hidden tests. So I'm going to go ahead and submit this. In the meantime, let's see what our guy Firefly has to say. Firefly solved this one by building a matrix. Ooh, that's interesting. All A's in the first row, all B's in the second row, etc. Then another loop to check that each row length isn't longer than the previous row. Right. So you're talking about like a matrix where like each row of the matrix isn't necessarily the same length then, right? Like there could be like three A's in the first row, maybe 2 B's in the second row or something like that. Am I sort of getting the idea right there? Yeah, exactly. Okay, right, and then empty arrays like for all the ones that don't have any characters. Okay, so if you have time, can you touch on how inefficient that is compared to the method you're using if you have time? Oh, hey, yeah, for sure. Yeah, definitely. Oh, and look at this. It passed the hidden test, so that's thank you. But anyway, not right now. The point is, okay, so Firefly, what I would say about your method, and just, okay, I'm going to copy what you did here, what you pasted in, just to sort of show. Like, you're basically talking about using a matrix, like producing a matrix that looks like that, right? So where you just take all the A's, take all the B's, take all the C's and D's. So your question was basically, can I comment on the efficiency of this versus how we're doing it down here? Well, I have a few things to say about it. So the first thing is, it depends on how you did it, right? Because like how you get it into this matrix is, it can really, the time can really depend on that is what I'm trying to say. Like it could take a very long time. It could take a very short time. Right now, I'm actually not using the most efficient method that I could be. I will use a more efficient method a little later on. There are just a couple more things we're going to talk about. But the one thing I do want to say about this is the space complexity would be my main issue with this. If anything, I would probably do this sort of thing where instead of saying like A, let's just say, well, actually, you know what? Okay. I do have a suggestion that's going to be sort of based on this. But I'm going to talk about it just a little bit later because there is one more thing that I want to do on like using this kind of strategy, and then we're going to sort of switch gears and we're going to look at a different strategy. So I'm glad you brought that up. We'll return to it in just a sec. For now, this was passing all the tests, right? It passed all the hiddens. Cool. So there's just this thing that I want to talk about just as a last kind of thing because, it does feel like, I don't want to say like it's cheating, but it does feel a little sloppy, I guess. I don't know. It feels slick in other ways, but okay, I guess the main thing is we want to be aware of our options, right? So the way we were doing it before is we were doing something like let character be assigned the value of A, keep looping up to and including the point when character is Z, and then just like increment the character, which the ++ didn't work, but anyway, we'll just do some sort of like increment character, something like that. We'll just put that in for now as like a placeholder. Here, I'll make it a string just so it's less offensive. Okay, but this is the main thing. Like, I do sort of like the idea that of like starting with a character that's A and then like iterating it until we can't any longer, or at least until we shouldn't any longer. So I do sort of want to try it that way, and then we'll move on to something else. But the way we're going to accomplish this is actually by using objects. So we talked a little bit about that right over here when we're doing this new RegExp thing. So we're going to make our own object, which is fun. I think we've done that before. I think we talked about like classes and stuff like that. But I'm gonna use sort of like an old school method of doing this. So we don't talk that much about OOP around here. Maybe we should. I don't know. But anyway, what I'm going to do here, this is actually going to be a constructor. Okay, so you might think, oh, that's weird that I used a capital C. That's kind of strange. You didn't use a capital C over there. And good point, yeah. The reason is because I'm talking about an object now. I'm not just talking about a function, I'm talking about an object. Okay. Now, what I want to say about this object is I want to give it a property and a method. So, what are properties and methods? We might as well talk about it. Properties are basically like pieces of information that an object holds, whereas a method is like something that an object can do. So, fortunately, we actually have names for like incredibly similar things. Basically, outside of the context of an object, instead of property, we would say variable. Instead of method, we would say function. So a variable that belongs to an object, we call that a property. A function that belongs to an object, we call that a method. So we use lots of methods and properties all the time. Like for example, inputString.match, that's a method. It's a method because we're using this as a function. I just noticed I missed a semicolon. Sorry about that. Anyway, so we're doing just any string. This happens to be input string, but every string has this .match method that'll take a regular expression as an argument. Also, matches. So matches here is an array. Every array has this built-in property called length. So we do .length, and that gives us the property of the array that is its length. Okay, so we want to define our own properties and our own methods for this thing that we're calling char or character. The point is, we want to say something like, this dot symbol is going to be assigned the value of start character. Okay, that's what it's going to start as. But is it always going to have that symbol? Well, no. And the reason is because of this method we're about to build, which is going to be called next. And it's going to be a function. And basically what it's going to do is it's going to reassign this dot symbol. What is this dot symbol going to be reassigned as? Well, basically kind of the thing we had before. So string.from character codes, that's a built-in method for the object string, and we'll do this dot symbol, so the current value of this dot symbol, dot character code at +1. And it just about fit. Let's get a little more room. We don't need to see that much of the description. This is where the action is happening after all. So okay, so we've got this character thing, and then we could do like, I don't know, let first character be assigned the value of new character. Let me move my cursor there. So just like what we're doing downstairs here with this new regular expression. So now I'm saying new character, and it's a constructor that takes an argument of start character. So what start character do I want to use? Let's go with A. Might as well. Okay, and then we'll just do return first character dot symbol. So since it is a character object, it should have a property called dot symbol, and that should be starting at a start character. Okay, so it's A, it's the thing that we want. But let's check if all of this is working. We can see that this property is working, but what about this method? So the way we'll call the method is, notice, and this is kind of important, this function doesn't return anything. Like we could if we wanted, like return, we did it, or something like that. But the main thing is we're not really that interested in what it's returning. We're interested in what it's doing. So now I'm starting with A, and then I'm calling next, and that's changing first character dot symbol into B. That's the idea. And we could even do something like let other character be assigned a value of new character with let's say P as the starting point there. And then, we could do like other character dot symbol, and notice like we can call dot next on first character. It's not going to affect other character. We could also call dot next on other character if we wanted to, and then it should become Q, I think, right? Yeah. And we can do this again if we wanted to. So what are we expecting? My alphabet's not too good. Yeah, R, that sounds right. Okay, so we can call dot next as many times as we want to, and it's only going to be with reference to a particular object. Now, the way this is working, just to be absolutely clear about this, when I do first character dot next, it's saying, okay, first character, it's a character, right? Dot next, basically where we see this, we're replacing it with first character. Okay, so when it calls this function, it sees this, it says, oh, okay, so you mean first character dot symbol is going to be assigned the value of string.from character code first character dot symbol dot character code at +1, and then it's going to return we did it. So like, for example, if I were to just pop a return on the front of this thing, it would actually show me what dot next is producing, and it's, yeah, we did it, this little celebratory string. Like notice we're not really returning any of these calls to dot next because we don't really care about that string. It's not that we're trying to get something out of it, it's that we're trying to change some property of the function, specifically what its symbol is. So that's the way we can do this. We can use this object, and let me get a bit more room over here so we can see it all at once. So I'll delete that line. And instead of saying that it's just going to be A, we'll say it's going to be a new character, which starts at A. And we want to go as far as character.symbol is less than or equal to Z. And then at the end of that, character.next. Ooh, that's nice. I hope it works. Let's find out. Doesn't look like it's totally working. No, it's definitely not working. It's giving us some big issues, actually. So why is that? Well, recall, character itself is now an object. It's not just the letter A or the string A. It is an object. It's an object that contains symbol, it contains next. And in fact, that's something I probably should have done. So let me get this space back in here. And I was doing something like let first character be assigned a value of new character. And we use an X for this one. And then, so we were doing something before that was kind of like this, right? First character dot symbol. Yeah, there's the X, great. But let's say, I don't want that. Let's say I just want to know, hey, what's first character? Well, it's this thing. It's an object that contains something with a key of symbol and a value of X. And, we could do something like first character dot next if we wanted to. And then when we run that, we should find, yeah, it's changing it to a Y. Okay, cool. So that's kind of neat. Like I said before, we don't really use a lot of OOP, which stands for Object-Oriented Programming. But when you can, it's a lot of fun. So basically what we're trying to count here is not the character itself, because that's an object. We're trying to count the character's symbol. Okay, and I think that's the only change we'll have to make. That seems to be running. So let's submit that and see where it goes. Okay, nice. That feels good. Now, is this the best method? I don't know. And I'm just realizing now, I've made a lot of modifications to this thing without really just, archiving the previous one. So, sorry. But anyway, if, you can always rewind if you want to take a look. Main thing is that we were talking about if this is the best method. And I'm kind of thinking like, well, I kind of can't quite get over the fact that it seems a bit like overkill to be defining this whole new object for just something so small like this, like if this was a larger scale project and we're going to be using a whole bunch of these characters, then yeah, I wouldn't hesitate to do something like this. Here, is it overkill? Maybe. I don't know. I don't know if we really need anything all that specialized, but hey, it's good to get in the habit of this OOP stuff. Now, actually, there was one more thing I wanted to say, because I started limit at 1E9, and that's like a really big number. In fact, I think we could even make it an even bigger, I almost said an even bigger number than that, but this is not a number. As you may know, it's infinity. Okay, so we can make it infinity. We can make it 1E9, which is like a billion. Or we could just make it, well, the biggest possible thing that it could be, which is the length of the input string. Because the only way this could happen is like, if all of them were the letter A. If every single one of the characters is the letter A, then this would be right on the money. It'd be exactly the limit we're looking for. So this is probably, the tightest way to do it. I think I like that the best, but like overkill isn't necessarily a huge problem, right? Like getting the problem done is the main thing. Getting it done optimally with like the best amount of effort, that's icing, that's to come next. But getting it done is the main thing, right? So overkill isn't necessarily a bad thing. Okay. So at this point, we want to draw our attention back to Firefly's method over here. So we were looking at this and we were kind of saying like, is this the first one? Yeah. So for this first one, we would kind of go through it and I'm guessing we would just sort of count one at a time, right? So we would just say, look at this first character. And by the way, Firefly, this is sort of what I meant when I was saying like, it kind of depends how you do this, right? Like if you're doing it sort of like the way I did, looping through the characters and saying like, okay, this first character is A. Let's go through the string and find every single instance of A and put it into an array and then push that into our matrix. that would be kind of less efficient. What would be more efficient would be to just go through each character one at a time and only loop through the string once and basically say, okay, this first one, what is that? That's B? Okay, well, it should go in the second array then, or array with index 1. That's also B. Okay, push that to the same one, and same with the next one. And then once we get to A, we'd say, oh, okay, well, that should go to the array with index 0. And push as many of those as you need to, and then this one should go to the one with index 2, and then to the one with index 3, etc., right? So that would make it nice and efficient, but the main, I guess, issue that I have with this, and okay, I don't want to make it seem like it's a huge issue, because look, I mean, like, the length of the string is only 50. Like, we're not going to have to worry very much about this. Like, even if it was 500,000, it probably still wouldn't be that big of a worry, but that's where it starts to be a little more costly. The point is, I'm looking at this and I'm thinking, this is legit, there's nothing wrong with it, but really at the end of the day, we're just going to be counting these things, right? So it feels a bit like a bit of overkill to me to be putting in a whole array here if all we really need is to know how many things are in that array. That's really the main information that we're looking for. So I'm thinking, instead of like pushing each of these elements into the array, maybe let's just do like a plus plus, you know, start with a 0 in there, and then I guess, yeah, these guys would be zeros as well, because this is ultimately the thing that we're looking for, right? Something that's kind of like that. So let's make that kind of our goal here. We'll go through the string once now, and we'll just do something like, well, okay, first we're going to do this character count array. And what's character count going to be? Well, I just want to start it off really simple and just do something like this, kind of an old school looping strategy here, dot push, and we'll just pop in a 0. Sorry, we'll push in a 0. Okay, and then after that, we'll just say something like for let character of input string. Then what are we going to do? Well, basically, we'll say let index, or maybe I'll be more specific, I'll call it character index. So let character index be assigned the value of character dot character code at minus a dot character code at, which, yeah, I know that's just the number 97, but I'm just trying to be clear about it. So, okay, character index is that, and then basically we just want to say character count, you know, like that thing you're counting over there, at this particular index, at character index, just add 1 to it, plus plus that thing. And then at the end, let's just for now return the character count and see what we're getting and see if it's kind of like the thing we're looking for. Yeah, it is. So basically, this is kind of what we're looking at, right? I think this was exactly sort of the part of it that we had written down. So then basically from here, all we need to do, as you mentioned, Firefly, is just loop through it, right? So we just say like for let, I guess I'll do it this way. I'm going to say for let I is assigned the value 1. I is less than, I almost said input string dot length, but what we mean is character count dot length, and then I plus plus. And from there, basically if character count at I is greater than character count at I minus 1, then return false. You know, that's the circumstance under which we want to say no. And otherwise, if it makes it through that whole thing, yeah, return true. Okay, so great. Saw how fast that ran? That was fast. Let's submit it. Let's see if it's passing all those hiddens. Oh, yeah, it is. Okay, so I like this one, I think, the best. I think this is my favorite of all the methods. We'll make it a little bit better by just doing this. Constant A is assigned the value of A dot character code at. Great, and then we can just subtract from that. Hey. And yeah, I don't know. I'm conflicted about this one because like we're doing like character of input string. I do definitely love doing a for of loop. I think those are a lot of fun. They're really nice. But I am kind of tempted to just do something like, you know, let I be assigned the value of 0. I is less than input string dot length, and then I plus plus. And the reason I would want to do it that way is just so I can just put that right in there, you know, just put the I in there, just so that it's not just like isolating the character and then asking it what its character code is, you know. Instead, we can just not split up the string and just say input string. That's the other important thing. Input string dot character code at I minus A. Okay, and hopefully that works. Yeah. Okay. Cool. All right, so I think that's working good. I mean, look, there are other ways we do like this stuff over here. There's like we can make a recursive function to sort of like build up an empty array of 26 characters. There are lots of ways we could do this kind of stuff. And look, there's lots of ways we could do all of this kind of stuff, right? Like, I showed a few different methods of like, for example, counting the character down here, but like, there are lots of other ways we could do that. There's like a sneaky one a lot of people like to use that involves dot split, but I actually, myself, not a fan. Anyway, okay, I think this one's working good. We'll submit it. We'll, yeah, okay, cool. So, okay, great. I'm glad we talked about that. And hey, look, Firefly, thank you for bringing it up. I think that's good. You know, it adds to the richness here. We're able to see some different styles of solutions, some different strategies here, and it's always good. So, okay, let's, how long have we been streaming? 46 minutes. Okay, let's take a quick break, and afterwards we'll move on to the next one. So we'll say bye-bye to isBeautifulString for the time being, and I'll meet you back here in a minute.